Hey, you guys. In this section, we're going to be talking about the law of cosines and the area formulas. Okay. So if you guys remember from the previous videos that we looked at, we were studying the law of sines. Okay. And both of these law of sines and the law of cosines are going to help us solve oblique triangles. And remember, an oblique triangle is a triangle that's not a right triangle, which means that it doesn't have a 90-degree angle. Okay, so when we studied the law of sines, we looked at case 1 and case 2 triangles. Case 2 was your ambiguous case, and case 1 was going to be your side angle angle or angle side angle. So both of these cases, we use the law of sines first. Okay, now we had 4 cases. Okay, so the 2 cases that we're going to look at in this lesson are side angle side, which is case 3, and side 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 triangles, which is case 4. We're going to use the law of cosines on these triangles first. Okay, so I'm going to walk you through the steps on how to solve each of these in the examples that follow. Okay. All right, so there's one thing we want to keep in mind anytime we're solving these triangles, and we want to remember that we need to follow the triangle side length restriction law, okay, which says in any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining side, okay? So that means if they give me the lengths of 3 sides of my triangle, okay, what that means is that you sum any two sides and their sum needs to be larger than the remaining side, okay? And that equation, that equality needs to hold for every single combination of sides, okay? So for example, you need to say A plus B needs to be greater than C, okay? A plus C needs to be greater than B. B plus C needs to be greater than A, okay? All right, so let's check. We have A plus B in this case, which would be 3 plus 4. And is that greater than 10? No, it isn't. Okay, so automatically this would fail. Okay, now this needs to hold for every single combination of sides. So for example, in this case, B plus C, these two sides would be 14, which is bigger than A. That would have been fine. Okay. If we would have done A plus C, that would have been 13. 13 is greater than 4. That one would have been okay, but it failed one of them. Okay, so your triangle that you've been given must pass each one of these inequalities. Okay, the sum of two sides must always be greater than the remaining side. If it isn't, okay, then automatically you have no triangle. Okay, so this is typically true, especially if you're solving for a side, side, side triangle. So before you even attempt to find any angles, make sure that your triangle satisfies this restriction law. Okay. All right, so here is our law of cosines. Okay, so our law of cosines says in any triangle ABC with sides A, B, and C, remember lowercase letters signify sides and uppercase letters signify angles, then we have these 3 different versions of the law of cosines. Okay, now they're pretty much the same. The only thing that's different is their letter placement, and that just is determined by what you're looking for. So if you're looking, for example, side A, then you are going to sum the squares of the other two sides. Then you're going to subtract 2 times those two sides times the cosine of the angle to the side that you're trying to find, okay? And that combination is all the way down. So you just need to use the version of the formula depending on which side or angle you're looking for, okay? All right, let's try our first example. So our directions say to solve the triangle ABC if A equals 42.3 degrees, B equals 12.9 meters, and C equals 15.4. Okay, so just like when we were solving triangles for law of sines, I'm always going to draw a triangle first. Okay, doesn't have to be perfect. I'm going to label my angles first, and then I'm going to label my sides. Remember, sides are across from the angles they face. And I'm going to put in the information that I've been given. So angle A is 42.3 degrees, little b is 12.9, and little c is 15.4. Okay. All right, so like always, I'm going to go ahead and fill in a table just so I can keep track of what I have and what I'm looking for. Okay, so little c is 15.4, little b is 12.9, and a is 42.3. Okay. Now, we need to classify what type of triangle we have. So we have a side, angle, side, and the angle is included in between the two sides. So this is a side, angle, side triangle, okay? So anytime you've been given a side, angle, side triangle, we're gonna follow these steps. So the first thing we're going to do is we're gonna use the law of cosines to find the third side, okay? Then step 2, we're gonna use the law of sines to find the smaller of the two remaining angles. And then step 3, we're going to use the angle sum formula to find the remaining angle, okay? So another reason, so even if you had forgotten those steps, okay, I know I have to use the law of cosines first on this problem because I don't have a combination, okay? So if you guys remember from the law of sines, okay, you knew you could use the law of sine first because you would always have a matching angle and a matching side, for example, okay? We don't have that, so we automatically need to use the law of cosines so that we can either find the side or the angle so that we then have a combination. Once we have a combo, then we can use the law of sines, okay? So I'm going to find the third side first. So that would be A for us, okay? So I'm going to find A. Oops, change it back to pen. Okay, so the law of cosine says if you're looking for A, the A squared equals B squared plus C squared 2 times BC cosine of A. So I'm going to plug in the information that I have. So that's going to be 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times the cosine of 42.3. Okay. All right, and I'm not looking for A squared, I'm looking for A. So that means I'm going to need to square root this number once I get it. So 15.4 okay. And once I plug that into the calculator, all right, and then I square root it, this should be my answer, 10.5, okay. All right, and that should be in meters. Okay. All right, now I need to find either B or C. So our directions say we're going to use the law of sines to find the smaller of the two remaining angles. Okay. So you may be asking, well, how am I supposed to know which one of my two angles is going to be the smallest? Well, the cool thing about triangles is that angles correspond to their sides, which means that the smallest side is going to be across from the smallest angle, and the medium size side is going to be across from the medium angle, and the large side is going to be across from the large angle. Okay, so if we're looking at our sides A, B, and C, okay, 15.4, that's the largest, okay, which means that angle C is going to be the largest angle. Okay, and then 12.9 out of 10.5 and 12.9, this is going to be the medium one, okay, or the middle one, okay. So between B and C, all right, B is going to be the smaller of the two angles, okay, because it's across from the smaller side when comparing B and C, okay. So we're going to look for angle B now, okay. So when I look to find angle B, okay, I can use the law of sines now to find it because I have a combination. I have both the side and the angle for A. So because I'm looking for angles, uppercase letters are going to be in the numerator. Oh, I'll write the formula for you guys, just in case you forgot. So sine of A over A equals sine B over little b. I'm going to plug in what I have. I'm going to cross multiply. And I need sine B by itself, so I'm going to divide by 10.5. 12.9 sine 42.3, 10.5. All right, I'm going to plug this decimal number into my calculator to get a decimal. When I do that, okay, I get this. Okay. So for if you guys are following me, so for my calculation, I actually left side B, what was that? Side A as 10.47. All right, so just take note of that. I actually rounded it to 2 decimal places. Okay. So if I want to do that, let's just correct that for you guys. So you guys get the same answer that I will have. 4747. 47. There we go. So when you plug that into the calculator, you're going to get 0.829231. All right, and I'm not just looking for this decimal, I'm actually looking for the angle that has this as a sign value. So I'm going to need to take the inverse of this decimal to give me my angle. And when I do that, I get 56.0 as my angle measurement. So that's angle B. Okay. And then the only thing left to find is angle C. Okay. So since we already have our other two angles, I can say 180 minus 42.3 minus 56. And that will give me my third angle, which when I plug that into the calculator, I get 81.8. 81.7 degrees. And so I've officially solved this problem, and I know that I'm done because I have the measurements for all 3 sides and all 3 angles. Cool.